Okay, horizontal and vertical components. This is just checking you're okay with resolving your components, which you should be, and with the vector side of it, really. So alpha is the angle of projection above the horizontal. So alpha is measured from the horizontal to the direction of motion initially. And then the motion of the projectile will create this parabola shape. And we can resolve U into horizontal and vertical components. So the horizontal component will be going that way. And you could call that U subscript X if you want to. And then the vertical component will be going up this way. You could draw it in there, but it's sort of quite nice to pop it in there. And so U subscript Y for the vertical component. You might well see a capital U used here, I'm not entirely sure why. And then if you want to resolve horizontally, then the horizontal component is U cos alpha, because you want the adjacent, and the vertical component is equal to U sine alpha, because you want the opposite side essentially to the angle. So we've just been doing that, so you should be fine with that. And just a couple of quick examples. So the first one, we've got a particle projected. U is 40 meters per second at an angle of alpha to the horizontal, where tan alpha is 3/4. So we've spoken about this already. If tan alpha is 3/4, then opposite over adjacent, and then you can find this hypotenuse using Pythagoras. It may well have a square root in it. I don't know why every single example in the Excel books, because I've been using them a lot, is a 3, 4, 5 triangle. So it's 5 again. So to find the horizontal component, we're going to need cos alpha, which is equal to 4/5, so adjacent over hypotenuse, and sine alpha is equal to 3/5. So the horizontal component on this one would be 40 times cos alpha, so 40 times 4/5, which gives you 32, and the vertical component is 40 times 3/5, so it's 40 sine alpha for the vertical component, because you're wanting the opposite, and that's equal to 24. And then once you've got your horizontal and your vertical, you could write U as a vector, and that would be 32i plus 24j, or you could use a column vector, so 32, 24. So essentially it means that we've gone along 32 and up 24, but we'll go that way. And then you can start using SUVAT on the vertical horizontal motion, but we'll do that next lesson. So then you can start projecting from angles which aren't horizontal. One more quick example. A particle is projected with velocity 3i plus 5j. Find the initial speed and angle of projection. So I think you should be fine with this, to be honest, but it's 3i plus 5j, so it's being projected like that. That's alpha, so that's 3 and that's 5. And so to find the speed, use Pythagoras. So square root of 3 squared plus 5 squared, which is root 34. I haven't used G yet, so I'm going to leave it like that. Seems to be far too accurate, but we'll go with that. And then tan alpha. Mechanics is a weird mixture of exact form and then going, oh, it's still one so big. Tan alpha you're going to be asking me about that now. 5 over 3. And so alpha is equal to 59 degrees. So tan alpha opposite over adjacent. So we've been doing this in vectors a bit. So that should feel quite comfortable, but you should be able to go from component form to magnitude direction form, and essentially from magnitude direction form to component form. And so just a few questions on that as well.